So Jensen's alpha measures the difference between the actual return of a security and its expected return, which is based on its beta risk. So that's what we're looking for in this question. So first, let's find the expected return. To do this, we're going to use our calculator to run a regression on the given data. So to do this, we have to enter in the data as a collection of ordered pairs of points. For each year, we enter the market rate first, and then we enter in security J's return. So we're going to go through the process of this, how we're going to construct this regression using our financial calculator. So we start with year one, and again, we enter in the market rate first. So the question tells us earn 10% in year one. So we enter in 10% as a decimal, 0.10. We press input to tell the calculator that we're entering an ordered pair of data, a point. We enter in the return on security J, which was 18.17%. So we enter in as a decimal, 0.1817, and then we press sigma plus, and that tells the calculator we're done with this ordered pair. So we do this again for each year. 0.12 is because the market earned 12% in year two. Input, security J earned 21.15%, so we enter in 0.2115, and then press sigma plus. In year three, the market earned 10%, and the security earned 18.17%. In year four, the market earned 16%, and the security earned 27.11%. And in year five, the market earned 12%, and the security earned 21.15%. So the most important part here is just to remember you have to enter in the market first, then press input, then enter in the securities return, and then press sigma plus to tell the calculator you're done with that set of data. So now we have to press 0 to find the slope. We're looking for the slope of this regression, which is going to represent the beta risk. So first we have to press 0 to tell the calculator we're looking at the axis only. We're ignoring any input of a market percentage. Then we press shift, and then we press y hat comma m. And that tells the calculator, again, we're looking for the intercept and the slope. Y hat is the intercept. So when we first press shift in this button, we get 0.0327. That tells us, again, the intercept of this regression. This regression is basically just a line of best fit based on the points we're giving it. Well, we want the slope because the slope represents the relationship between security J and the market, and that represents the beta, which is what we're trying to find. So we have to press shift and then swap to get it to display the m, which is the slope, that's 1.49, and that is our estimate for the beta of security J. So we can use cap m to find the expected return. Again, this is the expected return, what investors expect or require based on the beta risk, based on the slope that we just estimated from these points. So cap m tells us the required return on security J is equal to the risk-free rate plus the market risk premium times the beta of security J. Well, we're given the risk-free rate is 4%, the market risk premium is 8%, and we just found the beta risk of security J to be 1.49. So we find that the expected return on security J is 15.92%. So now we have to compare this with the average return of J over the last 5 years. Well, the average, we just add up the returns each year and divide by 5. So this 18.17%, we got that in year 1. We got the 21.15 in year 2, 18.17% in year 3, 27.11% in year 4, and 21.15% in year 5. We add all those up, divide by 5, and we see that J's average rate of return was 21.15%. Again, Jensen's alpha is the difference of the average rate of return and the expected or required rate of return. So Jensen's alpha is the 21.15% minus the 15.92%. That gives us an alpha of positive 5.23%. Now the sign on this is important. If Jensen's alpha is positive, it means that your security actually overperformed expectations, so it did well. If Jensen's alpha was negative, it means that your security performed poorly.